Solve the polynomial inequality and graph the solution set on a real number line. Express the solution set in interval notation. We have this polynomial inequality. The polynomial is x squared minus 22x plus 121. And then our inequality is less than 0. So with polynomial inequalities, we want to start off by finding the boundary points. And that means solving the equation x squared minus 22x plus 121 equals 0. So I replace that inequality with an equal sign. These boundary points, if you're thinking of this graphically, like a two-dimensional xy graph, these would be your x-intercepts of the polynomial. So let's see if we can solve this by factoring. If not, we can always rely on the quadratic formula. So I know that x times x is x squared. 121, I think that's 11 times 11. And I can make them both both minuses, because negative 11 times negative 11 will give me a positive 121, and negative 11 plus negative 11 will give me a negative 22. So I've got that factored correctly, and then I'll set each factor equal to 0 with the zero product property, and that gives me x equals 11 and x equals 11. Now, I only need, because those are repeated, I only need one of them, and I'm going to put that boundary point on the number line. And when I put it on the number line, I can also take note of that original inequality. Notice it's a less than. Less than doesn't include equal to. So this boundary point will not be included in our solution set. So we know that 11 is not part of the solution set for this inequality. And now what we need to do is test whether the interval to the left of 11, so numbers less than 11, are part of the solution set, or numbers greater than 11 are part of the solution set. So we want to pick test points in each one of those intervals. So I'm going to pick a test point, and the only rule is that it has to be in the interval. So we need to pick a number that is less than 11. So I'll pick 10. And in the other interval, I'll choose a test point that is greater than 11, so 12. And what you do is you take that test point and you substitute it into your inequality to see whether you get a positive or a negative. So let's substitute x equals 10 into our polynomial. That's 10 squared minus 22 times 10 plus 121. 10 squared is 100. 22 times 10 would be 220. 100 plus 121 would be 221. And we have 221 minus 220 would give you a positive 1. And so that means in this interval, our y values will be positive. Then I'll test x equals 12. So if I test x equals 12, I get 12 squared minus 22 times 12 plus 121. 12 squared is 144. 22 times 12 is 264. 144 plus 121 is going to give me 265 minus 264 is a positive 1. So in this interval, my y values are positive based on that test point. So when I go back to my original inequality, in order to make this inequality true, I need the y values to be less than 0. I need them to be negative in order for them to be included in the solution set. So my intervals came out positive, so they're not included in the solution set. And my boundary point is also not included in the solution set. So this inequality has no solution. If you want to think of this graphically, the graph is going to be a parabola shifted to the right 11, and it would look something like this. And so you can see down here where the y values are negative, the graph isn't present on that part of our coordinate plane. So we have no solution to this inequality. Thank you for checking out my videos. Have a great day.